were due today, I believe like now. And if you need more time or anything, feel free to shoot me an email. I can extend that. But I did make 8.1 and 8.2. I made those due December 6th. When is that? Next Tuesday. So I did extend it. I didn't want to push it much past that, I think, and I made it at midnight that day. Just because the final is Thursday. And so I'm going to have to grade your final probably Friday and do final grades on Saturday. So I don't want to, cut it too close and make the homework due like a day before I have to enter grades. And, if anything is having a syncing issue, like so I want it to be done or settled. So next Tuesday night, your last two homeworks are due. And I will probably on Wednesday before your final, I will probably sync all the grades and go into Blackboard and just check, and anything that's missing, I'll put a 0 in for. Like if there's a homework that, I don't know, it didn't register or you never started it, or, you were out that week, whatever. If that's missing, I'll just fill it in with zeros. So it also gives you like a few days to then notice, oh, hey, I did this homework, and it didn't register or whatever. And you could screenshot your grade on your end and like email it to me and I can update it. Right. So just please keep this in mind. And I really want you guys to know, that like I can't individually check every single homework and every single grade, but I am going to do my best to just make sure it makes sense. Right. Like if I see somebody has a 12 in the class out of 100, like overall, okay, clearly either like they didn't do anything or something is wrong, right? So I will be checking overall grades. And I did update, someone emailed me about this, but I did update in Blackboard your final grade. Everything is calculated percentage wise. I was able to update that, I think, last week. So the tests are whatever, 20% each, and the homework is 15%, whatever the percentages are on the syllabus, that's what I updated. So hopefully you can see a really good idea of your grade for at least for now or before the final. And remember, the final only covers everything since the last test, right? So that's like 11.6, 1, 2, and 3, and then 8.1 and 8.2 from this week. So do keep that in mind as well. Okay, and without further ado, now that I've bored you to death, we will get started. Okay, if my pen will work, please. I charged this. Okay, cool. So today we're 8.1 is polar coordinates, and polar coordinates are something that is a little bit obscure or abstract to think about, but and I used to not like it as much, but I actually really like it because some things can be a little bit easier this way, and other things maybe are just the same, but look different. And so our motivation for this is these. Well, so what you see here, R is theta. So R in this case, in this circle, you can see here. Let me draw a little for you. So if I, and R would be if I want to extend, like say to this point on the spiral, right? I could drop down and form a 90-degree angle to the X and Y. Okay. Oh, that doesn't look like perfect, but okay, pretend that it looks nicer. And R would be technically, if I was to extend and like look at, this circle here that I chose, although it's changing, R would be that radius, but it also happens to be equal to this theta because it's changing. So this is kind of different than what we're used to, because we're used to one circle, one radius that no matter where you go, this is R, this is R, this is R, right? That's what we're used to. But now we're looking at something like this where it's this spiral image that's constantly changing, the radius, the angle, whatever it is. And we in this particular case, it's R equals theta, but there's going to be an equation that we use. I think it involves E, but maybe that's not true. And then you can create something like this spirograph image. Right. So maybe you've seen these before. And this kind of goes back to one day where I mentioned like and now the stethoscope or something, whatever it is, or whatever it is that stethoscope is like a doctor's thing, isn't it? But whatever it is that like you can kind of look through and shift the shapes and see, this is kind of what it reminds me of, like this image, right? And I think hopefully, I mean, I want to say we did an application problem at the end of this, but maybe we don't. I think we do an application problem at the end with something like this image. And so that's going to be our motivation to learn more about this kaleidoscope. Thank you, Michelle. Yeah, you got it. So to learn more about this image and like maybe how it's formed, what's going on with it, because it's very symmetrical and very like interesting and unique, right? And as you move it or shift it, in like a kaleidoscope, it looks different. And now there's just probably kids don't know what kaleidoscopes are. They just watch YouTube videos, right? And it does the same thing. So to start here, we want to plot points using polar coordinates. So just like when we're on the XY plane, we have this thing called a coordinate, and it's X comma Y. Polar coordinates involve R and theta. Okay. So first we can look, and we consider the pole is going to be like the center of our, of whatever, circle graph we're looking at. And what we want to see here is, if we go, so say we just go one circle, like one unit out, that would be this circle, right? And that brings us, to the unit circle, but this is like very zoomed out. Then we could say, okay, what happens if I go 2 units out as I keep extending and I get to this circle, right? And if, like in this image, if we were spiraling it, we're going from the radius of 1, then we go a little bit further to the radius of 2, and you can create this like picture, right? Now, what we see here is a point. So if I was to draw like a line like this to a point, right, an ordered pair, normally we're used to X comma Y, but now our point P is going to be R comma theta, right? So it's going to be R comma theta. And notice R goes first. And this isn't to say that it's necessarily like related to the X value, but maybe sort of, right? Eventually we will get some equations where we relate these, but R goes first and theta is second. And this is just how we list the points, the ordered pairs. And what we're doing here is we're now thinking, instead of saying before where like this and this was like the X and Y axis, instead of doing that, now we're saying, okay, we have just this axis right here. And notice how this is the only kind of bolded and labeled axis. And this is the polar axis. And now our points are going to look different because they're in terms of R and theta, which R is that distance that you see here, right? R is this distance from the center to our point. And then theta, so instead of having X and Y, we now have theta. So we now have this angle in our relationship. And so we're going to be able to calculate some things, or just, at least for now, we're going to look at what are polar coordinates and, how are they useful. And from what I remember in calculus, I want to say they come up more in calculus, which is maybe why they're at the end of pre-calculus or in chapter 8, but they're not regularly or often used, I would say, because they're a little bit strange. So if we want to plot these points, and remember, so in this next one, like this is R.
So what does R stand for something?
So it's like it's the radius, really, because it does come back to like X squared plus Y squared equals R squared. And then it does come back to like R equaling sine and cosine with theta. Like it comes back to these relationships, but and right now I don't exactly, I feel like we're going to get to it. I don't know why we haven't yet, but yeah, okay. So it's it's like after a few examples. And so we are going to get to these equations and you'll see how they're related.
Yeah, so hopefully that helps. Okay, so we just want to plot these. So again, we are now, instead of thinking of this as X and Y, we are thinking of this, and this is like a bit strange, right? But we're thinking of it as like just angles. Look at all these labels. We start at 0 degrees and we go up, and they're labeled in both degrees and radians just because both, that's what we're using here. And it's the same thing, like if you were to go negative, it's not labeled here, but like this is -15 and that's +15, -30, +30. So it's the same idea that the distance, or that like this is positive angles, and this way is negative angles. It's the same idea as on the unit circle, right? And so what we want to see, well, this first one, it's 3. And notice how like this isn't labeled like 1, or this isn't, normally we're used to this being 1 because it's the unit circle, but it's not labeled that. And this is because we don't know, like they're different, right? All of these are different and we don't know what it's going to be. And so I do think they go by like, this is 1, 2, 3, 4, 5, I think. So they're saying each circle is 1 unit. So our radius goes out 1 each time. And, the center point is 0. So if we want a radius of 3, then we know we're going to be on this 1, 2, 3. We're going to be somewhere on this third circle, but not where we're at depends on the angle. So normally we're used to like, 3, 2, and we know we go 3 over, 2 up, there's the point, right? But now we know, okay, we're on this third like polar circle, right? We're on this third circle and my angle is pi/4. So that's right here. And so I know that I can draw, okay, if I can connect this right. So here's my angle. And this here is pi/4. So my point is right there. So this is the point for A. I'll just label it A. And now what I want to see, okay, the next one. So B, let's look at B. So -4. Okay, so -4, this just means it's probably going in this reverse direction. So it's still 1, 2, 3, 4, right? So we're still looking at, we're going to be on this circle, right? And I don't know if it's helping them highlighting, but we're going to be somewhere in that circle. And because it's negative, it kind of tells me that it should be pointing towards the negative side, but we'll see. And so the angle is pi/6. Okay, so this, because of the negative, this is the same. So we're pretending that our 0 kind of starts here. Like we're pretending that 0 starts there. And well, okay, this is kind of a bit strange. And you're like rotating this, and the positive direction is down and negative is up, which is a bit strange, but this is going to be the same thing as if I wanted to make this positive. What I do with the pi/6 is I add pi. So pi/6 plus pi, which tells me 4 and then 7 pi/6. Because I'm rotating, basically what I'm doing by making it negative is I'm rotating 180 or pi degrees or pi radians, right? I'm rotating it pi. And so I could either make the R positive, because that makes a little bit more sense to us, or I could, and then I add pi to my angle to rotate it appropriately, or I have to think of it as negative, as my radius as negative, but then my whole circle is kind of like, you'd almost want to, which if I do this, the iPad will turn with me, but you almost want to turn your paper, if it's going to be negative, upside down like 180 degrees. And that's how you're viewing it. Okay. So, so in this case, it's the same thing as this, which if this makes more sense to me when it's positive. So I see it's going to be on that green circle I highlighted, which is radius of 4. And the angle is 7 pi/6, which is this guy right here, right? So I know it's going to be here and there. Now, if you weren't sure, what you can do, this negative, if you didn't know how to change it right to this, you can say, okay, it's on that fourth circle, and I know where pi over 6 is. Pi over 6 is here. So what you can do, let's see if I can get this. Okay. So what you can do is you can go to pi over 6 and you can say, here's that point, but then you can reflect it over the origin, across the origin, like on a diagonal, and this is your new point, right? And this is B. So you can reflect it if you want to make everything positive, but just remember, in order to make up for this negative here, you'd have to just then reflect it, right? Because this initial point that I drew, this point that I drew right here would be the point 4 comma pi over 6, not -4. So there are different ways that you can view this. And I think, well, hopefully, you can kind of find the best way for you and the best way that makes sense, right? Now I see C is telling us 2.5. So, okay, I know I'm not going to highlight this because maybe I've highlighted too much, but I know it's going to be like in between 2 and 3 and along that type of circle. If I was to draw, right, like I'll erase this, but if I was to draw a perfect circle in the middle of those, right? And then -4 pi over 3. So this tells me I have to go in the direction of the negative angles. So they're not labeled here. So you could just follow the pi's over 3. So every time you see this is like -pi over 3, then -2 pi over 3, and -3 pi over 3, because that's just pi. Then so I'm looking for all the thirds here, right? And then -4. Oh, I'm off a little bit. -4 pi over 3. So this is the same thing as +2 pi over 3, right? Is the R exactly the X value? Yeah. So, but we're not really thinking of it as X, but it is, the R is the X value. If you're looking at this like an XY axis, right? The R is simply the X value. Yes.
The length of the...
It's the radius, right? It's the length of the line, right?
Yeah.
Which we're finding it by going on the X axis and then it's on that circle somewhere. Yeah. So in this case, I know it's going to be on 2.5. So it's on this line and 2.5. So just about there, right? And there we have it. And this is C. Okay. So we did that. Okay, let's see D. 7 and 9 pi over 4. So this one isn't so bad because we just know we go out to 7 and then 9 pi over 4. Well, this whole thing is labeled for us, right? So it's kind of nice. Except let's see, where is that? Oh, maybe it's not so nice. So I see 7 pi over 4. But what's happening with 9 pi over 4 is that it's going all the way around. This is 7 pi over 4, then 8 pi over 4, then 9 pi over 4. So it's actually here. It's doing, because 8 pi over 4 is 2 pi. So it's doing one full 360 degrees plus a little extra 45. So we actually just end up at pi over 4. And so that's going to be, okay, pi over 4 and 7. Oh boy. Okay. So it's out here, but I'll just kind of, I don't want to write over part A, but it's on that same line, but it's just further out. And so this is D. So, and what we noticed was, oh, maybe I'll write it in same as 9 pi over 4. And if you still are like, how is this the same? This is 2 pi plus pi. Okay, and this next one, or the last one, is -5 pi over 6. So again, well, doesn't really matter how you do this, but I like to say, so this is same as 5 and 5 pi over 6 plus pi. So 11 pi over 6. So 5 11 pi over 6. Okay. So now let's go out to 5. I see 11 pi over 6 here. And I want to be on the 5th circle here. And so something connects there. And this is point B. Well, and I think the lines are less important. So I drew these lines. These lines are not actually a part of it. So I think in your book, what they do is they put arrows on, they put like little arrows instead of lines to show I'm starting from the middle and I go out to this point. That's how or this is the point I'm traveling to. And so all of these, like they don't technically need the lines because we're just plotting points, right? So just keep that in mind that, okay, I'm maybe adding these lines, but it might not at all be necessary. Which now I'm realizing, I think your textbook just dots them all or like puts arrows so that it's more clear. So something like this. So we're going to look at 2 more points and then we're going to look at the equations and how these are related to x comma y, right? Because they are related. Like I said, they're related via x squared plus y squared equals r squared, and then also via some trig, like right triangle trig. Okay. So number 2 says, given the point 3 is 7 pi over 6, find 2 other polar coordinate representations with r bigger than 0. So basically what this just means is like, let's plot this and then you can either add or subtract, pi or 2 pi or something to your angle, but keep that number, that r, the same, right? So let's take a look because they give us a little graph here. So in this problem, they give us r equals 3, theta is 7 pi over 6, right? So I know 1, 2, 3, I'm going out to 3, and 7 pi over 6 is here. So I go around, and that's this point right here. So there's my point. We can call it P, point P. Now, in order to get something else, we can do a few different things. We could either get the negative angle and keep r positive, right? So we could figure out, so we looked at this angle like all the way to here, and that's 7 pi over 6. But now we can look at, from 3, what is the angle here? Because that's going to be the negative of this. And that's going to give us one answer. So if I want to figure that out, I can just follow the pi over 6s and figure out, how many, well, okay, you can't do it like the thirds, but like this is negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, and then negative 4 pi over 6, negative 5 pi over 6. So you actually have to follow the thirds as well, right? Because they reduce. So like negative pi over 6, all right. Negative 2 pi over 6, which is pi over 3. Right? Negative 3 pi over 6. Negative 4 pi over 6. And this is negative 5 pi over 6. So this angle is negative 5 pi over 6. So then that means that another equivalent point would be 3, negative 5 pi over 6. And then we want to find one more. So to get the other one, we can just add any multiple you want, really, of 2 pi, right? Because what that means is if I add 2 pi to this point, right? What I'm saying is, okay, I'm going to go one full circle, and then I'm going to go back to 7 pi over 6. So I'm going to go 2 pi, then 7 pi over 6. So let's add that. So 2 pi plus 7 pi over 6 is, let's see, this is 12 pi over 6. And you could also subtract it. You could also add 4 pi, as long as you're adding the right amount of pi's or the right amount of 360 degrees, like full circles, to get you in that same spot, then this is correct. So we have, what's this, 19 pi over 6, I believe. Yeah, so my other answer would be 3, 19 pi over 6. And there's infinitely many correct answers here. I'm just starting with what I think are the easiest ones. Get the negative and add 2 pi, right? But now this one's asking less than 0. So this is kind of tricky. It's saying, given this point, find 2 other polar coordinate representations where r is less than 0. Okay, so it's starting off positive here, and we want it to be negative here, right? So we want our answers to be -2, comma, some angle, and -2, comma, some angle. So first I'm just going to figure out where this angle is and what 2 pi over 3, what that actual point is. So let's do that. So like this actual point is 2, and then where's pi over 3? Pi over 3 is here. So this is the actual point, right? And so from here, what you want to do, if you're making r negative, remember, if you want that same angle, so if you want the exact same point right there, but r is going to be -2, then what we normally do, so if I had, so just as an aside, maybe if I had -2 pi over 3, how would I graph this? Well, I would change it to +2 and then pi over 3 plus pi, right? Because it's rotated 90 degrees. So this would become 4 pi over 3. And what that means is that if I have -2, 4 pi over 3, this is the same thing. So 4 pi over 3, where's that here? So 2 comma 4 pi over 3 is the same as -2 pi over 3. But we want it to be the same as this guy here, right? And so if I just kind of reverse this, and what we did was we can take this yellow point and reverse it all the way to its opposite, which is 4 pi over 3. And so now we have the right angle. And if it's -2, then we know once it's graphed, it's going to be flipped and it's going to be that yellow point again. So it would be -2, 4 pi over 3 as one answer. And then you could add 2 pi to that, or you could get the negative of that, which is the same thing as saying, like in this case, 2 pi over 3 minus pi, right? Because you could add or subtract the 180, doesn't matter. And this gives us pi over 3 minus pi, -2 pi over 3. Yeah. So -2 pi over 3. And again, if I was to graph this, I mean, there's so many different ways you can do it, but if I was to graph this second one, I might say, okay, what's 2 -2 pi over 3 look like, right? Then reflect it. So I would go, oh, 2, and this is -2 pi over 3, and I would be here. And then I'd say, oh, reflect it for that -2, and I'd be back at my yellow point. So we're kind of just moving, I mean, the negative on the R is just moving these points back and forth, right? They're moving them, from kind of one quadrant into another. And so the answer, I guess these were the answers here. And again, there's many other correct answers. I was just getting 2. As long as those angles are equivalent to 4 pi over 3 and -2 pi over 3, then your answer is correct. Now there's a total typo here, which I'm just noticing, and it's crazy because I've probably looked at this a lot. It should be convert, not covert. Convert between polar and rectangular. So I guess that was my bad. I should have known. X, Y coordinates are like rectangular coordinates, and it's because the coordinate system is like based off of a T, like basically a square or a rectangle, right? So these are our rectangular coordinates. And if we want to convert between these, I'd say, let's see, we have, so this, if I make this triangle, right, and this is a right angle, this distance is y equals r sine theta, right? If I'm using right triangle trig, because it's because y is this point, and it's the opposite, or sorry, sine of theta is opposite over hypotenuse, which, oh my God, what is the opposite? Y over r. And that's how we get this. And then cosine is this guy, right? Because this side is just y and this side is just x, right? That's how we get up to this point. And so x is going to equal r cosine theta, because cosine theta, just thinking of SOHCAHTOA, is x over r. And then here's where, well, you already know this one, x squared plus y squared equals r squared. This is still true. And this is one way that we can kind of convert these. Now, one that we maybe haven't gone over before is tangent. So you can actually get tangent theta by, we know that tangent equals what? Sine over cosine. And we know sine is y over r, cosine is x over r, right? So we can take these, plug them in, and then simplify and get y divided by x. So these two equations are the main equations. I mean, these as well, but these are the main equations that, maybe I'll highlight all of them, right? That help us to convert between polar and rectangular coordinates. Because sometimes maybe you're just given x and y, and then you can solve for r and theta using these equations. And then sometimes you might be given r and theta, and then you can solve for x and y with these equations, right? Okay, so now, well, it's a bit funny because now, I mean, we just wrote that out, but hey, repetition is good. But now it's written out for us. So polar conversions. So it's basically what it's telling you here is that to convert polar to rectangular, you basically just need these equations. And then to convert rectangular to polar, you really just need these two. So those four, I mean, that we just wrote above are the ones that you need. But what we want to know is that these equations, you want to consider, you really want to consider all of these, but they're saying, oh, if you specifically are given a polar to rectangular, this is what you do, and then vice versa, right? But you really want to, for equations, you want to consider all of these. Okay, so now let's actually try some examples, right? So convert the ordered pair in polar coordinates to rectangular. So notice how what they're asking is polar to rectangular. So that's going to be my guy up here, right? And so r is 3, theta is 5 pi over 3, r and theta. And so I'm going to start by writing, okay, x equals r cosine theta. And y equals r sine theta. And then the good thing here is, well, we do have to remember a unit circle again. So 5 pi over 3, this is related to pi over 3. And because it's cosine, its x is still positive. Wait, 5 pi over 3, because it's over here. Yeah, because it's almost 2 pi. So it's in the 1, 2, 3, it's in the fourth quadrant. Yeah, so x is still positive. And actually, okay, why am I talking so much? It's right here. So we know that x is still positive. So this is 3. And the cosine of pi over 3, this is 1/2. And I think sine is root 3 over 2. So this is 1/2, right? So this is just 3 over 2. That's our x number. And then y is going to be 3 times, now look at where we are. Y is negative here. So you can think about it in terms of pi over 3. Like if you know, oh, this is 1/2 root 3 over 2. But then this down here is 1/2 negative root 3 over 2. So this will be negative root 3 over 2. And now this is negative 3 root 3 over 2. And here's the cool part. So, well, this is our answer. So our answer in xy is just 3/2 negative 3 root 3 over 2. If we were to plot this, so if I plotted 3 and 5 pi over 3, it would be 1, 2, it would be here. And if I thought of this as xy, like as x and y coordinate plane, right, the rectangular, this point that we just plotted, it is the point like 1.5 or 3/2 negative 3 root 3 over 2. That is the exact value of the x and y, right? So that's pretty cool that we can get that. And we can do the same for number 5. So I see 3 pi over 4, which I should just, is right here. And again, it's going to be the same coordinates as pi over 4, but the x is now negative. So negative root 2 over 2, 2 over 2, right? And these points that we're getting, they're specifically for, well, so I probably shouldn't label them on the circle, but they're specifically for the unit circle. So maybe that's what I should write on unit circle. So that's when the radius is 1. We're not necessarily in that world anymore where we're assuming it's 1. We're not there, but we are using sine and cosine as if the radius is 1, because now we're multiplying by our radius, right? So we can assume like this is unit circle. So these points specifically are only, they're not like if I put a point at the end here, that's not the exact point, right? Because that's actually 1, 2, 3, 4, 5, a radius of 5 out. Okay, cool. So now we have x equals 5 times cosine of 3 pi over 4, which is 5 times negative root 2 over 2. So negative 5 root 2 over 2. And y is 5 sine 3 pi over 4, which is just 5 times root 2 over 2. And so my ordered pair is negative 5 square root of 2 over 2, comma, positive 5 square root of 2 over 2. And if you think about it, it's, where's that point? 1, 2, 3, 4. Oh, shoot, wait, 1, 2, 3, 4, 5. Oh, the point actually is right here, right? It's on the very edge. And if we were to say, oh, what is this based on this polar coordinate? What's the actual xy value? It's this. It's negative 5 root 2 over 2 and positive 5 root 2 over 2. So now I think we're doing the opposite. We're converting the x and y coordinates, the rectangular, to polar. So notice how, so now we kind of have rectangular to polar. So we're going to be using, well, it's way up there, but that's what we'll be using, right? And now it is specifying r is greater than 0, theta is between 0 and 2 pi. The reason for this is because we could have r be negative, right? And we could have theta be some other crazy, really big or really small, like, or negative angle, but they want us to get like the reference of it basically. And so we're gonna just say let's assume r is the positive value that you get, and theta is between 0 and 2 pi. So they're restricting that domain just so that you can get, because there's like multiple answers here. So just so that you can get a answer, and that answer is the same that we all get, right? Otherwise, I'd be sitting here, if you were grading this or on the homework, actually, I'm curious, it probably specifies, because then it would have to know, oh, any of these plus 2 pi or minus 2 pi, could be the answer. And it's like, okay, it's kind of a lot of work. Although you could probably just program that some way to recognize it's a little bit of work. So let's start. This is our x, this is our y, right? And I know I'll start with r squared equals x squared plus y squared, because we can find r. And then we can go ahead and use tangent. Well, it doesn't matter where you start really, but then we'll use that tangent theta to find theta. So x squared. Okay, so x squared would be negative 3 root 2 squared plus 3 root 2 squared. Okay, so this becomes 3 squared times 2 because you square each of these things, right? So it becomes 9 times 2, which is 18, but I'll write it out. And then this is also 9 times 2. So it's 18 plus 18, which is 36. Okay, so this is nice because now R, we get plus or minus 6, but remember they told us use the positive. So this means R equals 6. And then to get theta, we just use tangent theta equals y over x. And so this equals 3 root 2 over negative 3 root 2, which is just negative 1. So we have tangent theta equals negative 1. So then theta, I mean, you might be able to figure this out yourself. Well, and actually, I guess we might need to just because your calculator will give you a decimal. So what we want to see is where is theta? So what we want to think about on this graph right here is tangent theta equals negative 1. Where is tangent theta equal to negative 1? And it's not going to be a pi over 4. It's one of the pi over 4s because they're the x and y are the same. And when we divide, we just want to get a negative. So it can't be in the first quadrant because they're both x and y are both positive. It could be in the second quadrant, so potentially here, right? Can't be in the third because they're both negative. And it could be in the fourth quadrant. So it could be either of these. So our angle and our radius is 6. So 1, 2, 3, 4. Oh, wow. They didn't even, okay. Hold on. Maybe we're going to have to extend this a little bit. So pretend there's like one more circle all the way around, right? Okay. Okay. So really this, it could be here, right? Could be this point with 3 pi over 4 as the angle, or it could be this point over here with 7 pi over 4 as our angle. Now, you want to keep in mind that, well, all of these are between 0 and 2 pi, right? So, so basically, we want to figure out where, based on our radius being 6 and our radius being 6 and our angle being either 3 pi over 4 or 7 pi over 4, we want to figure out where would this land if, like, which do we want to be negative, the x or the y? Now, okay, it's kind of silly now that I say it because it's like, okay, look at the point they gave you. So this should tell you x is negative. Notice x is negative and y is positive, right? So if you notice that and you look at these two options, this point or this point, you should know that like at 7 pi over 4, x is positive. So we actually don't want that one because we want the actual x and y values here. We want x to be negative, y to be positive. So I was making it too difficult, but it's actually pretty obvious. So now we can pick and we can say, okay, theta is 3 pi over 4 because 7 pi over 4 would make x positive and y negative, which is not what we want. Now, if we picked negative 6, we would want potentially 7 pi over 4 or maybe negative pi over 4, because then the negative 6 would reflect it, right, back to the point that we want. So, so this, I mean, it depends on the point they give you, but it's also, you can also think of it like, oh, I picked a positive radius. So my point, it has to be exactly where I want it. It's not going to be reflected at all. And so now, well, now what do we have? Now our polar coordinate here is 6 comma 3 pi over 4. For number 6 there, that's the answer. And then for number 7, we're going to do the exact same thing, right? We're going to think about this the same way. So I'm going to start with,
So can I ask you a question?
oh yeah.
If R is greater than 0, if you're choosing the positive one, and is it always going to be in the same quadrant as the rectangular coordinate?
So yes. So because you're not flipping it at all. If you were choosing the negative one, which I think on the next page we do, then you have to think it's going to be reverse of the coordinate they give you because you're going to reflect it with that negative radius.
Okay. Okay.
Yeah. Yeah, that will always be the case. It's very nice and symmetrical once you see it all. So here we have r squared equals, remember this is x, this is y. So it's 4 plus 4, negative 4 squared, so 16. So is that 20? So r is plus or minus the square root of 20, which we know it's the positive one, but 20 is 4 times 5. So this is like 2 root 5. Okay. So r is 2 root 5. And then to get tangent theta is y over x. So this is negative 4 over 2. So negative 2. Okay, so this is where we're going to get decimals because we can't figure out where tangent is negative 2. We don't know that, right? So what you want to do here is you'll say theta is the inverse tangent of negative 2. And when you do this, this theta is negative. So this theta is negative. So sorry about the dogs. Okay, so sorry about that. Someone was at our door, so that's weird. Okay, like who knocks on your door anymore? I don't know. So where are we? So we're getting this inverse tangent, and then the angle you get is negative. I don't know why I don't have the decimal for this. But when you do this in your calculator, you'll get, I mean, you should do it in radians because I think, well, that's what we're doing here. But it's negative. So what you want to do is you want to add 2 pi so that theta is between 0 and 2 pi, right? So what'll happen here is the angle you're getting is like, okay, the angle you get is some angle here, and it's like negative, like this is theta, and this is the angle you get. I don't know the exact number. We will find it. But what you want to do is if you add 2 pi, so here's that angle. If you add 2 pi to it, it brings you to the same angle, right? Because this is 2 pi all the way around. So it brings you to that same angle, but it's positive. It's between 0 and 2 pi. So that's what you want to do. So basically our point here is going to be 2 root 5 is r, right? And our theta is this that I haven't written yet. So the exact answer would be inverse tangent of negative 2 plus 2 pi in radians, right? So this is the exact answer. However, we are going to get that approximate. It didn't say, I don't think. So I guess we're just going to do both, but I think your homework will ask for probably both or one or the other. So 2√5, and then we have, oh, and actually maybe we can make this a decimal as well. Because maybe that will kind of mean a little bit more. So 4.47 about, and then 5. I got like 1.8 about, right? So, and this is in radians, right? So this is theta, this is r. And if you look at the point, I mean, where it is, oh, well, okay, the x, y, so the x comma y, what I was talking about here, like the reason I knew it was here is because x is 2, y is -4. So I knew the theta had to be like somewhere down in this fourth quadrant. And that's how I knew if you get this small negative, like you would have gotten, negative, I don't know, negative point something radians or whatever. And you would know, okay, that's clearly, well, 1, it's negative, so we want it to be positive. And 2, I know where it's located. So now if I just add 2 pi to it, I can get back to where I want and I can get this answer. Yeah. Okay.
It makes sense.
Yeah, good. Oh boy. Oh my gosh. I thought I was going to delete everything. Let's not have that happen.
Because you have theta, I mean, you want to, is that why you use radians? Because
yeah, so I use radians because I think, I don't know, I think I want to say that majority of the time here, radians is what will be used. I actually am not even, so polar coordinates are always in radians.
Okay.
I mean, okay, typically, like, yes, you can do degrees. It's the same thing, right? Oh, and Jakob, yeah, thank you. So, okay, 63. So this is 63.4 degrees, if that's what you wanted. I think math people also, you don't need a label for radians. So they like that because otherwise you
Mm-hmm. I think we lost her.
All right, it happened again. So here we are. I was like, oh my God, everyone's frozen. And then I'm like, wait, okay.
Sorry.
No, it's okay. You guys are good. So let me just share this. We'll see when my computer or if my computer reconnects, hopefully by the end of class. But now I just can't see the chat. So it does say it's going to connect again, but it's just Outlook not so good. But okay, so hopefully that made sense. But I was just saying, like, yeah, you have to include this degree symbol if you want to, if you want to have degrees, which is perfectly fine. I think majority of the time in your textbook too, it will just do radians, but and I would assume if it doesn't ask like degrees or radians, I would assume radians, right? So just for your homework and stuff like that, if it doesn't specify, I would just assume radians.
Okay.
Yeah.
So
okay.
those were.
So yeah, sorry. Say that again.
Well, those are points. Now this next section is about equations.
Yes. So those are to get the points. Right. Exactly. And now we're going to convert actual equations. So I guess what I should have said here is when we're doing equations, you have to do all 4 of these, which is why I think earlier I was saying like, oh, consider all of them. You're going to have to consider all of these for equations, but only 2 at a time for points, right? And let me actually see. It will go crazy though if my audio is on for both. And it's not even connected, so I don't know what the heck. I do think part of this, okay, and this is just me going off, but I think part of this is like ACC, like the whole 2-factor authentication. I swear it locks me out. Like, you know how you have to enter your you know, oh my gosh, what is it called? You have to like enter a code on your phone, right? Or whatever. I swear that if I haven't done that, like it's mad at me. And so it just says, no, you cannot go in here. Okay. Well, I am back on my computer, but maybe I'll stay on audio on my iPad. I don't know if that'll be good or bad, but you can just holler. But now I can see the chat. Well, if there will be anything in the chat,
I wonder if you can opt out of that, or I don't use two-factor authentication for ACC.
Oh, I do. Well, okay, so that's a good question, and they force me to do it. I know, for like Blackboard and freaking whatever. Like my email, like I have to do it for my email, which is so annoying. And so I can actually do this though. Okay, perfect. I'm back. Sort of. So that's like a really good question. I'm not really sure, but if there is a way I can opt out of it, I would totally do it. But I think I met with when I first started at ACC a year ago, I met with a professor, like they give you like a little mentor professor. And she initially told me like, oh, if you want to do like a double password instead, because she's like, you're always going to have to do this. And she said she never has her phone on her and it's so annoying. And I was like, yeah, you're telling me. I mean, it's very annoying. And so I think she figured out a way that you can like have a code, like you still have to do it, but you don't have to get a text from your phone or whatever, or like the app. You don't have to do the factor authentication app or whatever. But I was too lazy or too busy and couldn't figure it out. So yeah. Okay. So now we're converting equations in rectangular to polar coordinates. Now, when it's just X or Y, it's kind of easier, right? Because X equals R cosine theta from our equations above. And this is we know that this is just a vertical line, right? So this means that X equals 12 equals R cosine theta, right? And so to get R, we can just say R equals 12 divided by cosine theta. And then to make this really nice and not have fractions, we can say this is, remember, 1 over cosine is secant. So this is 12 secant theta. And there's our formula. So the formula, well, okay, I'll write it nicely. 12 secant theta. This is a polar coordinate equation for a vertical line, right? Now you'll see for a horizontal line, it's very similar, but the trig function is just reversed, right? So it's y equals r sine theta, and so y is -6 equals r sine theta, and so r equals -6 over sine theta, so r is -6 cosecant theta.
So if you were to graph both like X equals 12 or okay, would they be the same or?
Yeah, so that's a good question. So right, we should graph both of these. So y equals -6 would be like, okay, if I go by twos, -2, 2, right? It would be something like this, and x equals 12. 2, 4, 6, 8, 9, 12, right? Yeah, we'll look at both of these. Okay, so this is x equals 12. This is y equals -6, right? Now, if we were to graph the polar version of this, it is so. I mean, you could plug in points and just try to figure out where it's at, but you can also notice that. So r equals 12 secant theta would be something like this. It would go to a point where 12, I think it would be, I think based on theta, how did I get this angle? Let me see. Because I'm trying to think secant, because when I get 1/2, but it's times 2, so it's not 12/24 though. I think somehow I get 12.7, and now I'm thinking this point is wrong, but there's a way where your X value is always, so what happens for a polar coordinate equation is you just have a bunch, this is R and theta, and you just have a bunch of lines, like a bunch of these.
Okay.
And granted, I'm not drawing this to scale, but each of these are R distance and they're theta. So I shouldn't draw the ones in the middle, but like maybe you'd have 2 here where this is theta and this is R, and there's 2 examples. Then from there, all that changes, your R stays the same. All that changes is, maybe my theta goes around and around and around and around and ends back here, right? So you have these circles. Yeah. So it doesn't, it's weird.
Interesting.
Yeah, good emoji, Yago, but it doesn't look like a line. It's consists, because it's really coming from a circle. So it consists of, well, in this case, it consists of only these 2 points, because if I was to draw a circle, that passes through these 2 points, it's only those points that, granted, then you could, well, R is going to be different here, right? So based on R, it's whatever 2 points land on our vertical line. And same thing will go for the horizontal, but it will be a little bit different, because it will be like, say we go to this, the theta will be here and the R will be here. And then maybe you have another one here, right? With theta and R. And this is like, so this is the circle where this distance is R, and your thetas are very specific here. Yeah. So I don't know where the 7 came from. I feel like this is wrong. And I think I made that up. So I don't know if so ignore the number, but there is a way. Yeah, there's got to be a way to figure it out. It's based off of theta. So it's based off of theta. So or of R. Like, we don't know either R or theta, right? Because we don't know, because Y could be anything. So actually, Y could even be anything. So this point, like if I chose, I think what I was thinking about is if I chose something like 12.7 and I just chose that Y is 7, then we know we can do X squared plus Y squared equals R squared, and we can figure out R, and then we can figure out theta and figure all this out. But for the time being, we don't actually know what this point is, right? We just know it's 12 something, right? Y. And so whatever Y is, that determines R and theta. But you could pick any point, because I could pick this point on the line. I could pick this point, but then the counter to that, if I picked a point here and I said, maybe it's 12,2 or something, then my R is exactly the same. It's the same here. And then my theta is whatever my new, so it's not the same as the blue dots that we initially drew, right? So you can always find 2 points that go together for R and theta, but based on every Y value, it's going to keep changing. And I think I must have just chose 7, and maybe I tried an example, but same thing for here. So if I picked this yellow point, this would be my R, and my theta would be this small angle or whatever this angle is, right? So, and we could pick a point really far out, same thing, like a point out here and out there, and my R would be a little bit longer, but my theta might be tiny. My R would be longer and my theta would be, right? So something like that. So that's what this looks like. And typically with an equation, you're not going to be asked to graph the equation of the polar coordinate, because it's more so just a point, right? And it varies based on what you pick for Y, at least in the horizontal and the vertical. So now we have, this one is an equation, right? So now this is going to be slightly different. And we know that X is R cosine theta and Y is R sine theta. So we are going to just substitute these in, and we're going to try to make some type of equation in terms of R and theta. Okay, so it's going to look a little funky, and this we definitely aren't going to want to graph, because it's just Actually, you could probably do it in Desmos and it would be cool. Or I don't even know if Desmos graphs polar. You could probably Google some type of online graph that graphs polar coordinates or something like that. Okay, so I have 2 and then times r sine theta minus 5. Oh, cosine. Whoops. All right, good thing I caught that mistake early. 2 times r cosine theta and 5 minus 5 r sine theta. And this equals 4. So now basically what I want to do is just get r by itself, because I want to solve whenever we do any of this. And you'll notice like up here, we solve for r, right? Because r, I mean, even though r is kind of like quote unquote rx, in this case, we want an equation and r kind of acts like y, right? So we want an equation in terms of theta for our radius. So we want to factor out r, so factor r, and we'll get r times 2 cosine theta minus 5 sine theta equals 4, right? And so we get, what did I do here? Oh, so then we just divide both sides. So oh my goodness, no. Divide both sides by this whole long thing. And this is why I was saying, like, there's nothing you can really simplify here. So it kind of looks a bit gross, I guess I could say. So 2 cosine theta minus 5 sine theta, right? We divide. And so then we get r equals 4 over 2 cosine theta minus 5 sine theta, right? And there's our equation based on 2x minus 5y equals 4. And that's based on a line. So if we were to, like, this is a line, right? It's like this first one was a vertical line, then a horizontal line. This is like a regular, you know, like whether it's positive or negative slope, whatever, it's just a line, right? Then this next one, part D, this is a circle. And it has radius 11, because this is like x squared plus y squared equals 11 squared, which is r, right? Radius 11. So this is just, I mean, if this is 11, this is just a circle. That's what this equation is. Now, in polar coordinates, we know, so here, we know that r squared is 121. And so r, now we can actually get r. We don't have to write an equation for it. So r is plus or minus 11. Now it does matter, like this whole, the plus or minus, but like you need to kind of include both, I guess, but we only need one to get the whole circle in polar coordinates. That's what's kind of cool. Only one to get the full circle. Like normally in XY, like in a rectangular plane, you need the both plus 11 and minus 11. Like the positive 11 maybe is the top half of the circle, the negative 11 gets you the bottom half, something like that, right? Or maybe the left and the right half and they go together. But in polar coordinates, we actually only need one of these, right? So what's happening here, and this is kind of crazy, is that our equation is just r equal to 11. Because the radius is always 11 here. And so sine and cosine just have to be 1. So our radius, okay, so you could do this. Okay, this is kind of overkill maybe, but x is r cosine theta. So r squared cosine squared theta plus, and then r squared sine squared theta equals 121, right? Which is r squared. Okay, so maybe I'll write it like this, r squared. So I could take an r squared out over here, and then I have cosine squared plus sine squared equals r squared. So this right here, it equals 1 by our trig identities, but also it has to equal 1 because r squared has to equal r squared, right? So this equals 1. And so our equation only involves the radius here. It does not involve our theta. And you can pick positive 11 or negative 11. Because then what's happening is every single point where the radius is 11, that's what we're plotting. And you would plot every single point where the radius is 11, and then you get the entire circle. And that's how the polar coordinate, that's how it would work, right? We don't even care that the theta could be whatever, because no matter what theta is, sine squared plus cosine squared is going to equal 1. Okay, so we have kind of 2 more cases that they're giving us. One is a shifted circle as part F. And then 2 is a parabola. So, part E, right? This is, okay. Part E is a parabola, right? Because I see a y squared, but I don't see, and I just see x is regular. Now, it might be a sideways parabola, but that's fine. And so in this case, I know this is r cosine theta, and I know that y is r sine theta. And so I'm going to rewrite this whole equation, and I'm going to say r cosine theta equals 4 times r squared sine squared theta, right? Because I'm squaring that. And so we can rewrite this and get 4r squared sine squared theta minus r cosine theta equals 0 if we subtract the r cosine theta from both sides. Now I can take an r out and get basically 2 factors. So let's take a look. So I can say r times 4r sine squared theta minus cosine theta equals 0. So this gives me 2 parts. This gives me r equal to 0, and this gives me 4r sine squared minus cosine equal to 0. Now we know that r cannot be 0 because then that's just the point in the middle, and that's not what this is going to look like, right? So this we can ignore this because r has to be greater than 0 in this case. And so now what we want to see is this, we want to rewrite this guy, and we want to add the cosine back over. So I'm getting 4r sine squared theta equals cosine theta, and then divide both sides by 4 sine squared. And we get we get an equation for r equals cosine theta divided by 4 sine squared theta. And you don't need to simplify that anymore. This is the equation we were looking for. Now, you can notice that on this curve, r could be 0 if theta was, I think if theta is pi over 2, we get like, if theta was pi over 2, we get 0 over 4. So it could be 0, but we are ignoring that piece of because this r equals 0 is kind of embedded in this equation anyways. But also r equals 0 is not the answer. Like we were looking for an equation with variables where we could get all the possible thetas and r's, right? So it is in here, like r equals 0 exists at theta equals pi over 2, but r equals 0 is not the solution, right? It's not the only solution. Okay. So now looking at this last one, part F, we know, so what we're going to do with this. So we know this is also a circle centered at, what, 5, 0, because this is like H and K is 0 and radius equals 5, right? But because it's not centered at the origin, we have to figure out, so this circle, it's technically centered at 5, 0, which is here. And maybe it looks something like this, right? And then, and so we have to figure out, like, what is this equation? Because otherwise, if it was centered at 0, it would just be like before, it would be r equals 5. But this is shifted. So we have to figure out how is the radius shifted in this case, or in polar coordinates. So what we're going to do first is we're going to square this and write it out. So x squared minus 10x plus 25 plus y squared equals 25. So looking at this is a bit strange maybe, but x squared plus y squared equals r squared. I'm going to replace that. Okay, so I'm going to say that becomes r squared, and I basically, and I basically get rid of these, right? Then I say, okay, subtract 25 from both sides because that eliminates that factor, so these go away. And then I'm just left with 10x, but remember, x is r cosine theta. So I'm left with r squared minus 10r cosine theta equals 0. And now I can do exactly what I did for the previous problem. And I can say r times r minus 10 cosine theta equals 0. So I get, again, r equals 0, which, again, we ignore it. We don't consider that as an answer. And then I get r minus 10 cosine theta equals 0. So r is 10 cosine theta. And remember, r does still equal 0 at pi over 2. So this exists, like it exists, but just it's not our answer, right? So our final answer is that r equals 10 cosine theta.
When you say it exists, I'm just...
Okay, so it exists as in the radius r can equal 0 at theta equals pi over 2. But the reason we ignore this initially is because we're looking for the answer in terms of r and theta. And if I just said, oh, r equals 0, I'm done. Well, I'm missing out on all of those other theta points where the r is going to be different.
Okay. Cool. Thank
you. Yeah. But this is going to be our final equation. And so what this is saying, I mean, ultimately in the end, is that this equation is the same as this equation in rectangular coordinates, right? These are the same equations, which is kind of strange, right? Looks strange, kind of seems a bit strange.
Wait. Say it one more time.
Okay, so this equation here in polar coordinates, or in a polar coordinate system, is actually the same representation as this equation in a regular XY coordinate system.
Okay.
And that's what we were solving for all of these. It's true for all of these. Like, I mean, the easiest one to me to see, like, visually is the one where it's just a circle, because I get r equal to 11. And that means that every single point on this circle, r is 11. I don't care what theta is. It could be anything, but r is 11. And so this creates a circle, but also this creates that circle too. X squared plus y squared equals 121. So that's kind of my favorite to see it, but I mean, it's true for the rest of them as well.
Okay. Thank you, Professor.
Yeah. And the last problem with many parts, as per usual, that we have here is converting the polar equation. So now we converted the rectangular coordinate to polar, or rectangular equation to polar. Right now we're going to convert polar equation to rectangular form and figure out what type of curve it is. Okay, so for this, what we want to do, Well, we know, keep in mind, we have x squared plus y squared equals r squared. We have tangent theta equals y over x. And so for this, and then we also have, okay, like x equals r cosine theta, y equals r sine theta. So these are all the equations that we have, right? And so first I want to start, if it's just r equals 15, this means r squared is 225. And this is x squared plus y squared. So my equation is x squared plus y squared equals 225. That was an easy one. This is just a circle. And this is, again, my favorite example. So r is constant. And so what type of curve is this? This is a circle. And it's centered at the origin. I mean, okay, you don't need to know that that's true, but we know exactly what this looks like. It has a radius, okay, a radius of 15. So, okay, I mean, pretend this is 15, right? Has a radius of 15. And there's our circle. Right, okay, very not drawn to scale. So maybe I should try to draw it to scale. So this would be like 15 up here. And negative 15, negative 13. Okay. Now B is just theta. There's no R here. So I'm going to start with the only equation that I can. Tangent theta equals y over x. And I would say this, and tangent theta is tangent of 2 pi over 3. Right? Which is, I mean, if you want to think of it, this is sine 2 pi over 3 over cosine, or if you can remember or figure it out, it is, it's going to be negative root 3 over 2 over 1/2. So it's just negative square root of 3, right? So maybe some people remember this, maybe not. But eventually you'll get the negative square root of 3. And this is equal to y over x, which means that I can multiply both sides by x. So I can get times x times x. And I can get that y equals negative square root of 3x. And this is my equation. And theta is constant, means we get a line. Means we get a line. And it's also through the origin because 0, 0 is a point here. So if you were to graph this, I mean, it looks something like, something like this with going through 0, 0 and then some type of points. And what we're looking at with the polar coordinates is that this theta is 2 pi over 3. And same thing, I mean, going in either direction. So I did not draw this really great, and this would be like positive r. And then going this way would be negative r, because then it would be like negative pi over 3 or something like this, right? So that's if we're only given r or theta. Now, if we're given both, so r equals negative 8 secant theta. So notice this has both r and theta in the equation, right? So we want to consider, consider x equals r cosine theta and y equals r sine theta. So I'm going to rewrite this real quick as r equals negative 8, negative 8 over cosine theta, because secant is 1 over cosine, right? And then I'm going to multiply both sides by cosine. There are other ways that you can get to the same thing by substitution or anything like this, but I'm just kind of showing you what maybe the book suggests, or maybe this is not the book, I don't know. So these cosines cancel here, and we're left with r cosine theta equals negative 8. Now, looking at this, if this was sine, you would do the same thing. But looking at this, r cosine theta is the x, right? So this is x. So this equals x. So x is negative 8. So this is actually This is it. This is just a vertical line. Now, this last one is a bit strange. It's probably the strangest one. And it's because if this sine was like cosecant, and we could do the same thing that we did in part C, or if it was secant, we could do the same thing, multiply both sides, then it would be great. It would just be a line, vertical, horizontal, who knows. But in this case, we need to get a little bit creative. So here, we're going to get creative. And what I mean by that is multiply both sides by r. So I'm going to say r squared equals 10r sine theta. And now I see something nice, because this is r sine theta is y, right? So I can actually replace this with y, 10y, and r squared. So looking up, I'm scrolling a little bit, I'm sorry. This equation here, r squared is x squared plus y squared. So this, oops, I don't want that. Okay. This is x squared plus y squared. So I'm going to say x squared plus y squared equals 10y. So it's still a little bit strange, but I can just rewrite this, right? And watch what we do. So this is going to represent a circle, because I see x squared and y squared, but that 10y is telling me I'll have to complete the square because it's not centered at the origin. So watch what I do here. So this is going to be a circle, not centered at origin. So need to complete the square, right? To find the center and the radius of this circle. So let's take a look. If I do that, I have x squared plus y squared. Then I do minus 10y, because I need that all on one side. And then I'll have plus blank, because I'm completing the square just for this part. And then I'm saying this equals 0. But whatever I add here, I have to add it here. So I'll say plus blank again, because you have to keep the equation balanced on both sides. And so remember, completing the square, we take this number, we divide it by 2, and then we square it. So that's 5 squared, which is 25. And this is 10 divided by 2 squared. And then what we can write, so now I can write this equation as x squared plus y minus 5 all squared equals 25. And so I can see my center, this is a circle centered at 0, 5, with radius, the square root of 25, which is just 5. And this is my equation. So that was probably the trickiest one, when you have sine or cosine and it's not in the denominator. But it gets you a circle that's just not centered, at the origin. Okay, so this is all we have for tonight. We're doing 8.2 on Thursday, and I'm not remembering. I'm sure there's problems I've skipped that I should be going over, but I am not remembering this tonight. So if there is something you want me to go over, I don't know how long Thursday will take, if it'll take us basically to the end or not. But if we do finish early, feel free on Thursday to bring some questions or ask homework questions or anything like that. And then a week from today, so next Tuesday, I will just review for the final. I want to check real quick if I've posted let me save this and let me actually get out of this. Stop sharing. Okay. And give me one moment.
Can't hear if you are speaking.
Oh, I was muted. Okay. So now we're back. So thank you. The test is a week from this Thursday, so December 8th. It's at normal class time. And if you have questions about it, anybody just let me know. I will not host office hours that day. I will just be on this meeting early. I'm making announcements again at the end. So McKenna, here you have it. So today we went over 8.1. I will post those notes to Blackboard tonight. Thursday, we will go over 8.2, and I will also post those that evening. And if you have any questions, we may have like 15 minutes at the end, kind of like today, for me to take questions. And then next Tuesday, I will just review. And what I wanted to check for you guys was, did I post on Blackboard any reviews for the final? If I didn't yet, I need to post them today. So I want to look.
Okay.
Oh, I had them scheduled for tonight. So perfect. So let me just like make them available. How do I do? Okay, so I have 2 reviews again for you guys.
Okay.
Let's try 17. All right, let's see what happens. Submit. So if you refresh your Blackboard, you should see one of them now. It is test 4 in parentheses final book review problems or book problems review. So that is the first one. Then the second one is going to be, I named it, okay, I'm just submitting. I named it test 4 practice problems, and it is practice problems that we will go over next Tuesday. So, and maybe we'll start this Thursday, but don't stress out about it. This Thursday you have a final 7 to 8. So yeah, Colby, I mean, I know Joseph, I think records, and I do record it, but I don't even, I can try to find them. I get emails that they're all recorded and all the chat is saved and everything like that. So if you do want, if you do want from, the recording on Thursday, I'd say first reach out to the GroupMe, but also, Colby, I can just shoot me an email because I can try to, either post it somewhere on Blackboard or figure that out. But typically they just, for ACC, they record everything. But because this class is asynchronous, which means you have to be here during class, I'm not allowed to share recordings. But for Thursday, you have a final. So this is, if anyone else is in the same boat, this is perfectly fine. But we actually should finish most of the notes before, not that you want to do class right before a final, but we should probably finish most of the notes within like the first hour of class. But I can definitely, either send me an email and I can try to get you a recording, or reach out to the GroupMe people, because I know Joseph keeps good track, and I'll post those notes for sure. Sounds good. Thanks. And so that's really the only announcement that, that our final is, we have Thursday, Tuesday, and then our final. And the final is normal time in class. I will have office hours. Today I hit some traffic. I was a little late, but I will be on Thursday. I will be on at around 5:15 before class. And then next Tuesday, I will also be on. But then on Thursday, I will not have office hours. So just keep that in mind. And if you need anything else, definitely shoot me an email. And in terms of question of the day today, I was going to ask, I think someone mentioned this before, but I don't think we did it. Your favorite board game or game to play. I mean, it doesn't have to be a board game. It could be like charades or something, but your favorite game to play, on a game night or, something like that.
Oh, Mancala, that's such a good one.
So, I want to ask you a question about the grades, real quick, because I'm trying to get tuition reimbursement through my job.
Okay.
And I was just wondering, so what is the earliest you? I mean, not to put, not to rush you or anything like that.
Yeah. So, okay, so our final is the 8th. I mean, I can probably, I would say the 9th. By the night of the 9th, I can have grades.
Really?
Yeah.
Okay.
Yeah, I'll probably stay up late that night. I'll probably have lots of energy and I'll start grading. And then Friday, that Friday I work, but I'll probably on my lunch break grade, and then I'll probably grade that evening. So yeah, I would say by the evening of the 9th or the 10th, like I should be, I know by the 10th, I want it to be done. Cause I think the university grades are due the 14th, but I wanted to just be done because, you know, we all have other jobs and other things to do. So I just wanted to get it done. So yeah, so I should have it within like a day or two of the final being done.
Okay. Thank you.
Yeah. And that's awesome that work will pay for some credits, right?
Yeah, I mean, it's kind of weird because I have to submit, I don't know, I have to submit the paperwork on, the deadline is the 8th, and that's the last day of our class. So I don't know how they expect, but I'm trying to figure out, talk to them and try to figure out.
Well, and you could, so I will update grades. What is today? I will update grades on the 6th from like all your grades minus the final, right?
Mm-hmm.
So if you, so on the 7th, I mean, if you wanted to tell them, hey, like, here's my grade, you know, without the final, because like that, they should be hopefully accommodating to like the final exam is that night, you know?
I think so.
Yeah, but that's Yeah. Okay. Mm-hmm. Well, and if you need, just email me if like for any reason they need, like want to be, me to email them or contact them and just say, oh, here's the grade or whatever, you know, that's fine.
Okay.
And yeah, McKenna said final grades are due 5 p.m. the 14th. Yes, that's true. I'm making it like for myself, I'm going to try to do it by the 10th, just so that, and really it's also so that I'm done grading. Then if you guys go in and look and you say, you put in a 20 instead of like a 70 for my grade, you know, like if you notice something, I just think, I think it's helpful because it's helpful to me, but also to you. Right. So yeah, so I will be done the 10th and it'll give you guys a few days to look it through and email me if you're like, hey, this doesn't look right. Can you fix it? Like, whatever.
Cool.
Yeah. Awesome. So yeah, so go ahead and throw in your board games there. And yeah, I see most of you did that. I'll stick around for like 2 more minutes. And then, you know, if there's no questions, I will see you guys Thursday. So thank you.
Okay. Thank you. Have a good night.
Yeah, thanks. Bye. You too. Bye. I'll post these notes while I'm thinking of it. Yeah, have a good night. Thanks. Thank you so much. Yep. Oh, I gotta check this. I'm about to post the notes for those of you still here. I'll do that in just a sec.
Recording stopped.
All right. Have a great night, guys. Thank you.